Yeah.
Good. Welcome back, everyone, towards the next session. And today it's my great pleasure to introduce a very gifted speaker, the CTO of Alone, Mr. Kishore Ayyadevara. And Kishore is a hands-on leader with a very deep interest in leveraging technology, data, and machine learning to help identify, communicate, and solve business problems. Basically, his core expertise is applied data science, and that's what he's doing on a day-to-day basis. Currently, Kishore is the CTO at Awone, a startup building products at the intersection of the metaverse and AI. So I'm really looking forward to hear a little bit more around that. He works across healthcare, retail, e-commerce, and financial services, and grew applied data science teams for more than a decade since his MBA in IT and operations in IIM in Calcutta. Today, he's going to talk about accelerating the value derived using artificial intelligence. So please give me a warm welcome to Kishore, and thank you so much for being with us today.
Awesome. Thanks, Jan. Thank you for inviting me here. We'll get started, and probably we'll get started with an image that sort of resonates with me whenever a project is just about to get deployed. Here is that image which you see on my screen here. Think of all the machine learning magic that is running in the back end, and think of that as a rocket for a moment, and all the infrastructure as the platform that is required in order to launch the rocket. And right at the end, you would find multiple issues that you would face where the project goes off the radar, or the project fails. It's not just me who is saying it based on what I have seen across industry, but also a recent survey that is conducted by one of the top data science websites called KD Nuggets, where in the survey that is mentioned over here, they have surveyed around 114 respondents who were responsible for deploying machine learning models to production. And what is astonishing is that a majority of them have said that less than 20% of the projects or the models get deployed in production. And again, reminding, a majority of the respondents have said that less than 20% of their models are deployed in production. And when we dig a level deeper, trying to understand why does this happen, that is where they said decision makers are unwilling to approve any changes to operations, or there were hurdles with respect to technical limitations of the machine learning models. Be it the model does not perform as well as it is supposed to perform, or there are some integration or implementation challenges for that particular model. And that is where the majority of the topic that we're going to discuss today stems from. How do we accelerate the value that we derive using AI? With the premise that if roughly 1 in 10 projects succeed, and on an average we take T units of time per project, how do we ensure that we increase the velocity of delivery for all of these 10 projects, so that we see faster iterations? And also, how do we identify which are the projects that are more likely to succeed? These are the 2 points that we will go deep. We will delve deep and try and understand some of the good practices that I have seen across my career so far. With that is the stem, or that is the content that we will be going through in the next 20-25 minutes, or roughly 30 minutes in this session, where I'll be talking about how do we accelerate the value that we bring from AI. Hi all, my name is Kishore, and I'm the CTO of Awone, an applied sciences company. I've been in this field of data science for the last 13 years now, building multiple teams or building products in companies within healthcare as well as in the e-commerce domain. Outside of work as well, I've been fairly active in the field of data science, where I've published 4 different books on AI and ML. I've filed 12 patents so far and authored 2 open source libraries. And as Jan mentioned, my interest lies at the intersection of business and technology, where the skills that I have learned during my MBA days back in 2010 in IIM Calcutta. Now, this session obviously would not have been possible without the incredible team Avon that is working in the backend. Abhay, Arunjit, Naga, Prashant, and Rohan. Some of their works, which will be demoed in the next few minutes. Now, let's look at the agenda for today. I'll be covering about deterministic versus probabilistic systems, essentially making sure that everyone is up to speed in terms of what do we really mean by a deterministic system versus what is a probabilistic system. Subsequently, we will try and understand where does uncertainty arise within a typical AI project, and given these uncertainties, how do we come up with decisioning, or how do we identify which are the products that are likely to succeed, is something that we will go through when we talk about the decisioning framework. And we will end with the accelerators, which essentially help us increase the velocity of our projects, which I'll demo through a use case. Or if we look at the agenda from a slightly different perspective, I think a majority of us here are here to understand how to accelerate the value derived from AI. And if you peel a level further, you will try and understand what are the people and processes that will enable this success from AI. And a level further down, what are the frameworks and accelerators that will help the people and processes to deliver success? That is what we'll be going to learn about, or at least my perspective, in the next few minutes. With that, let's look at deterministic versus probabilistic systems. Typically, when we think of any system, we are essentially looking at there is an input and then there is an output. In a deterministic system, we can code up the behavior with existing tools with 100% reliability. What is an example of that? Think of a scenario where you have to extract text from a web page where you already know the structure of the web page. All you need to do is parse that particular web page and you will get the content that you require. On the contrary, when we are thinking about a probabilistic system, we are essentially looking at scenarios where the behavior cannot be coded with the existing tools with 100% reliability. Again, an example of that is where we have to extract text from a scanned image of a handwritten document. Think of a scenario where my handwriting would be very different from another person's handwriting, and and in such a scenario, we still do not have a system that gets us with 100% reliability in terms of extracting text. There are quite a few tools that will probably get us close to anywhere between 80 to 95%, depending on whether it's a machine printed text or is a handwritten text, or in certain cases, whether it is legible versus illegible. But still, the keyword here is 100% reliability. And that's where I bring the distinction in between the two, where in deterministic, we can get the output with 100% reliability, whereas in probabilistic, we don't have that 100% reliability. Now that we talked about probabilistic versus deterministic systems, let's slowly unpack the title of this session. Let's focus on value. Now, how are we going to create value from a probabilistic system? Again, in order to understand how the value is getting created, we will look at a scenario where it's a deterministic system. And in a deterministic system, we can always scale the capability by automating the process in here. Whereas in a probabilistic system, we are essentially creating a new capability. When you think of extracting text from a scanned image of a handwritten document where there are no existing tools that would do with a high amount of reliability, we are now using those tools. We are creating a new capability which does the job for us to a great extent. Let's say 95% reliability, and now it's up to the human in terms of how do we use such a capability. Maybe in certain cases we might want the operations team to look at the transcriptions and then vet whether it is working fine or not. So in a sense, by having a probabilistic system coming from AI, We are creating a new capability, and now we can always scale this new capability to as much scale as we want. That's where value is coming from AI or the probabilistic system. A few examples in this case. Let's say if we are talking about predicting the probability of certain event happening, think of a scenario where we want to predict if a transaction is likely to be fraudulent or not. Or think of a scenario where you want the machine to see the world or observe the world. Think of self-driving car for a moment. Or think of a scenario where you have to read a corpus of text and then give relevant documents. That's information retrieval for search for you. Or think of a scenario where we have to interact with humans or slash customer service chatbots or recommender systems that we generally see day in day out, either on YouTube or Amazon. So if you think of all of these happen to be our probabilistic systems that have worked to a great extent and are the shining examples of where AI has delivered value. And what we have seen so far is, as we deliver more or as we implement more AI related projects, there is considerably more value slash learning that is coming from them. And once we have either of value or learning, that sort of is reinvested and better use cases identified, and this flywheel now has a positive effect in terms of getting value derived from AI. Well, that's more or less the positive side of it. But at the same time, there is always a con associated in such a scenario. And that's what we will look at in here when we are talking about uncertainty. And when I say the multi-headed uncertainty, uncertainty can arise in multiple dimensions. And we will go through each of them for each of the different example or the use case that we have looked at in the previous slide. So let's start with the first one. Let's say fraudulent transaction prediction. I've seen scenarios where fraudulent transaction prediction has resulted in hundreds of millions of dollars in savings for a business. But at the same time, that might probably be at the start of implementing the model. But what happens over time? Fraud transactions or fraud patterns evolve over time. So the question really is, how do we track them? And that's an uncertainty, or that's a question where we have to work very closely with business in order to reduce that uncertainty. Think of self-driving car for a moment. Even an accuracy of 99.9% is still not good enough if we are going for a full self-driving car, because even a 0.1% failure is catastrophic. So that's where it's an uncertainty associated with the technology. Can the technology give me 100% reliable solution? And that's the uncertainty again that we have to minimize, either by warning the driver or the person sitting in front of the wheel at the time when the model thinks that it is uncertain about the prediction. Think of information retrieval for search for a moment, where you have to scale your predictions or scale in order to go through billions of documents. And that's a problem where you have to solve the technology aspects related to scale in terms of going through billions of documents and retrieving results. Or think of chatbots for a moment, where you have to integrate across different channels, be it web, be it mobile, or be it on your own pages. And that's where integration is the challenge for us. And finally, let's say in the recommendation system scenario, where you probably need to prioritize based on multiple attributes. Think of a new viral video that just got out today versus a video that you have always been watching, but probably is not helpful in general for the society. So I think that's where you also need to be careful about what are the changes in data that are coming over time, or what are the new data points that are coming over time in order to retrain or give the more relevant recommendations. So if you think of it, uncertainty for a typical ML model is at different levels, be it at a business perspective, be it at the technology perspective, be it at scaling the technology perspective, or having the integrations in place so that the model can be used, or even at the very start where the input data or the data is not static but is varying a lot over time. And that's where I refer it as a multi-headed uncertainty, because there are multiple dimensions associated with it. With this background, in terms of the amount of uncertainty or the dimensions of uncertainty associated with this, let's try and understand how do we identify or how do we prioritize on, let's say, out of the 10 projects, how do I prioritize the order in which I would go ahead and execute the projects. So that's the first point that we will be addressing in the next few slides. Before we think about prioritizing, let's now think about what are the typical constituents of a ML system. You'll have to bother about the type of data that you're dealing with. It might be a tabular data, it might be an image, NLP, or audio data. Before I get there, Jan, am I still there? Just trying to be sure.
We can hear you, and we can definitely hear you.
Awesome. Just checking. Sure. We need to deal with the type of data, or similarly, the amount of data that is in place. There are scenarios where you will have a few millions of data points, versus there will be scenarios where you will have billions of data points. There will be scenario where at the time of prediction, you are looking at historical data, versus you will be looking at the more real-time data that you're getting in. And similarly, predictions are done in certain cases in batch, where the computations happen overnight, versus real time, where the computation happens as the event happens. There will be scenarios where we will have to address the question around accuracy of prediction, where certain use cases would require the high 99% accuracy, versus certain other use cases would not require that much amount of accuracy, given that they are potentially finding a needle in a haystack. In such a scenario, businesses are sometimes okay in having a lower accuracy but still increasing the recall. We will also have to worry about the hardware that is required for training and also inference, where during training you might be interested in having a few GPUs, or even you want to parallelly train it on multiple GPUs. And in the inference time, there might be scenarios where you're not connected to the internet and your predictions need to be made without a connection to the internet, where you will probably think of your Raspberry Pi devices, and you'll push your light models onto those devices, versus there will be scenarios where you do not have stringent requirements at the time of inference. Another scenario that we'll have to address is the number of predictions that we make. Think of the typical taxi hailing apps, where there are potentially thousands of concurrent predictions that are coming in at the same time, versus there are certain other scenarios where the number of predictions that are being made are not that high. And also, as we discussed earlier, latency of prediction, where we want to make sure that the user does not feel considerable lag, given that predictions are being made in the backend. And then finally, you will also have to worry about the concepts of data and concept drift, where essentially the data is evolving and changing over time, as well as the target that you're trying to predict is changing and evolving over time. And then finally, you might also be wondering about whether we should go with an on-premises or whether we should go with a cloud setup. Given all of these different elements that one has to think through while designing the ML system, now let's think of what is that framework, or what are the questions that I need to ask even before starting that project, so that I know if a project is likely to see the light of the day or not. One of the obvious questions that the business would be interested in understanding is, what is the return on effort from building and deploying the model? Again, it sort of um, uh, is different for two different scenarios. Think of a scenario where you're researching in order to build a model, versus think of a scenario where you do not have to do a lot of research and all the heavy work is already done in history, and all you have to do is know the path that you need to take in order to get your solution. Again, the amount of effort would differ between the two, which again would guide the return on effort in building and deploying the model. The second obvious question is fair enough. I can go ahead and build a model, but now are you sure that the relevant data that is needed in order to make a prediction is available at the time of prediction? Again, here we are ensuring that all the right data is available, or all the right infrastructure is put in place in order for us to make use of the model that we are going to build. An obvious question is, will the predictions have an acceptable accuracy? Again, at this point in time, at the start of a project, we probably would not know what is the accuracy of our model going to look like. However, we can always have draw parallels from the successes in history, where we try and understand what are the most similar projects that were done in history and what is the accuracy associated with those projects. At the same time, we will have to also be interested in understanding, can we make the predictions within the service level defined? Again, given the amount of predictions or the number of predictions that we make and the latency that is required, we should be interested in understanding what is the infrastructure cost that might be there in order for us to meet the service level requirements, and also understand what is the cost associated with the predictions as we scale for more number of requests. And then finally, we at the start itself, we probably need to understand how the data has been varying over time and how can I make sure that the predictions remain accurate over time. So if you think of it, all of these are the questions that one should think through even before starting a project, or in fact while shortlisting or prioritizing among all the list of projects that we have. Now, coming to the accelerators part, for each of the different problems that we have mentioned in here, there are certain specialized skill sets or specialized team members who would come in extremely handy. For example, when we are thinking about return on effort from building or deploying a model, here is where the business analyst and the data scientist would work together closely in order to come up with a number that can then be communicated to the business. Similarly, when we are talking about is relevant data available at the time of prediction, it is where the business analyst, data engineer, and the data scientist are talking to each other, trying to make sure that only the relevant data is picked to build the model, and the unnecessary data is not, or the data that is not available at the time of prediction is not picked in order to build the model. Similarly, when we talk about do predictions have acceptable accuracy, potentially this is where the data scientist comes in, as well as in certain cases, think of in the typical image or NLP related models. You would also have data annotator who would prepare the data for a data scientist so that they can go ahead and build the models. And if the accuracy of the model is not good enough, and the only way out is to increase the amount of data that is required in order to improve the accuracy, that's where data annotator comes in order to improve accuracy of the models. And then when we are talking about moving the model to production, or into the implementation, that is where data scientist and ML engineer work very closely with each other in order to move it to production. And also when we are making sure that the predictions now scale for more number of requests, that's where the ML engineer and DevOps engineer work hand in hand. And then finally, when we're talking about ensuring that the predictions remain accurate over time, that is where you have the ML engineer and the data scientists working together. So essentially, when we're talking about the people associated with improving or increasing the value from AI, it's not just the data scientist or the ML engineer who are associated with this. It has to be a team. And the A team here involves the business analysts, the data engineer, data scientist, ML engineer, DevOps engineer, and potentially a data annotator. So coming to the first mantra that I have seen is having a solid team where all these skill sets are present within the team. Now, essentially, what we have discussed so far is what are some of the questions that one should ask before prioritizing the projects, and two, what is the or who are those people, or what is it that I require in order to execute the project. Now let's look at the second one, which is how do I ensure that all these 10 projects are done within a shorter span of time, or how do I increase the velocity of these projects? Now, if you think of it, typically the data science tech stack has a wide array of tools, multiple frameworks, multiple programming languages, multiple ways of monitoring and deployment of the models. Similarly, the data engineering tech stack has an even more number of tools that are present. So this sort of brings the first question to the leadership, which is how do there is no standardized process that is available, and there are multiple options available for any given process. And similarly, the best practices are not necessarily institutionalized within an org, where you would potentially see data scientist one or team member one would solve a problem in a certain way, and team member two would solve the same problem in a completely different way. And if you think of it, there is a spectrum of elaborate to low code that people can work on. So now that sort of brings the vision for the accelerator tools that we're going to talk about, which is how do we enable standardization, how do we maintain low code, and how do we incorporate best practices across the org and also across the model building, testing, deployment, and the maintenance lifecycle. With that vision, the guiding principles for these accelerator tools also happen to be the inputs should be provided in a configuration file where the data scientist would not change a lot except a few parameters that need to be changed. And also, if there are any tools that the team member is not going to play with or is not going to use, let them be completely abstracted away from the user so that they don't have to deal with those tools. With these guiding principles for the accelerators in mind, some of the accelerators that we have built, both at Team One as well as in my previous companies, are around one stack is around data engineering or getting the data, and the other stack is around given the data, how do I go ahead and productionalize the model. So if you look at the left hand side where we are talking about auto airflow or snowflake stream or deep data quality, we are essentially looking at how do we ensure that we bring in the data at a much lower amount of time than it typically takes. That's through SF stream. And then the second one, we are also looking at how do we ensure that when we are bringing the data, we are only bringing the data that is of high quality and also flagging the anomalies that are present in the data. That is deep data quality for us. And at the same time, how are we ensuring that the processes are set up so that a new team member now does not have to recreate the processes but can leverage the existing libraries? That is auto airflow for us. So that's where, if you think of it from a data fetching and data quality perspective, the first three tools on the left deal with. The tools on the right talk about give once I have the data, essentially when we are talking about decide, once we have tabular data, let's say, how do I go ahead and build a model in the shortest possible time and also ensure that I can productionalize the model either on premises or on cloud in the shortest possible time? That's decide for you. Similarly, in FlowML, where you replace the tabular data that we were talking about in Decide with text data, and here is where FlowML comes into picture, where we can productionalize multiple NLP models, be it in classification or be it in named entity extraction, or even in the text summarization part. We would have tools or components within these tools that will go ahead and build and productionalize the models. In a similar manner, we would have dynamic computer vision here, where the three major components within computer vision, object detection, classification, and segmentation, are now done in 90% lesser time with a self-service for the end user. So this at a high level is what the accelerator tool does. One, reduces the time that it takes works across the major spectrum within data science, and three, standardizes the workflow for a team member, so that two different team members will have a similar working pattern. Now that we have briefly talked about these accelerators, I'll quickly walk you through a demo of how it looks like on a simple data set. So here is the simple data set that we would look at. Right now, I have imported the Auto ML tool that we have, where we are going ahead and initializing the multiple models. Here, I'm importing the data set, and I'm giving which are the dependent and the independent variables for us. And at the same time, now with a single press of a button, I'm running and ensuring that the model is now getting created, and our different iterations of the models are getting created. Once the model is created, the data scientist can then look at the different models and then ensure that or check the model that is of interest to them. And once the model is in here, we can also compute the predictions for these model on the data set that we have. So here we have the predictions. So by the end of this exercise, so if you think of it in this last 1 minute, all I have done is I have imported the data set, I've specified the target column, I've specified and I've trained multiple different models. And then I also came up with the predictions associated with the model. Now, again, when I relate that to iterating faster, here is where we are in terms of building a model faster. Now, I'm not saying that this would straight away ensure that your ML model is now built in a minute. A majority of the heavy lifting of the typical ML model, which is preparing the data set or identifying the data set, is still not being done in this one, where we are importing the data set straight away. Again, that's a accelerator that would vary from company to company depending on the kind of data that they possess, and that's why we did not build a common solution over there. But essentially, in here we have built a framework or a tool that goes ahead and builds a model given a data set. So far, we have looked at building a model given a data set. Now we will look at taking this data set and deploying this to AWS. So let's say in this particular case, I'll not be running all of these because this typically takes 6 to 7 minutes to create the endpoint on AWS, which I've already done. And once the endpoint is created, we can always make the prediction where we now have the predicted probability associated with the row that we are trying to predict in here. So that's where, if you think of it, potentially these tools have helped us in building and deploying a model in less than 15 minutes, given a data set. And in a similar manner, while this is on tabular data set, you would have similar accelerator tools for computer vision as well as in NLP exercises. That's a quick demo of this particular tool. And then getting back to what we have discussed so far, we have essentially talked about how do we iterate all the 10 projects in a much lesser amount of time. And also we've talked about how do we identify the projects that are more likely to have a disproportionate value and hence are prioritized. So yeah, that's a quick summary of what we have discussed, which is how do we identify or how do we identify the tools that will help enable a fast iteration for us. And similarly, we have sort of established that deriving value from an AI project is essentially a team game and not just of a data scientist or an ML engineer's responsibility. We have also talked about how do we prioritize projects even before we start the development, which is based on return on effort. And then we learned about what are the various uncertainties that are likely to happen at the different stages of a project. With that, I'll take a pause and again remind you of our company, Avon, which essentially is an AI services company which is helping other companies accelerate their AI journey. And please feel free to reach out to me if you have any questions. With that, I pause and I'm open for questions.
Thank you so much, Kishore. This was really, really useful. I actually learned a lot myself. I saw a couple of questions come in, and I also have some questions myself. So let me just first start with the questions from the participants. Let me project the question on the screen. And the question is coming from Anna. How do you determine relevant data is available? I think I saw that on one of your slides as well. And I think that's a very interesting question. So how do you measure, or what kind of success factors do you see there?
Sure. I think it sorry, it sort of depends on what kind of project that you're working on. Let's say I'll give an example where you're trying to predict based on the image of let's say an X-ray. You're trying to predict if the disease indeed exists or not. In those cases, you can always train your data based on publicly available or open source data set. But then think of a scenario where in your company, the data is available with a slightly different compression where it is available in a PDF format. And when you're typically training your deep learning models, the compressed image is going to be very different from the original image that you might have trained on an open source data set. So I think that's where the question is, do you have enough amount of compressed / PDF images of the exercise that you're trying to predict? So that's one way of looking at it. The second way, that's on the image data. Let's say if you're talking about tabular data for a moment, where let's say I'm trying to predict fraudulent transactions again. In such a scenario, I'm probably looking at, or I'm talking to this business analyst or the SMEs in here who are likely to say what are the most leading indicators of fraudulent transaction. And are those leading indicators captured within your data capture process in your databases? So that is where I talk about relevant data, where whatever you're trying to use in order to make the predictions, are they available at this point in time?
Could you say, just to expand a bit on that question from Anna, could you say that that is kind of like metadata around the data set itself in terms of its accuracy and relevance?
That's right. Yeah, metadata is one is definitely one of the key things that we would look at. And you would not stop just at metadata as well, though. You are trying to make double sure that the data is indeed accurate when you are going to leverage it to build
Okay,
your model.
that's a good question. If there are any questions, by the way, along the way, we still have a couple of minutes, so please feel free to submit your questions. One of the things that, and as a host, I can always ask the questions, so that's really interesting from my part as well. I was really triggered by your Flow ML example, which recently you went through very quickly on the screen. And one of the statements I saw on the slide was basically you could use this with very limited background in data science and without very limited knowledge around that. Yet, on the other hand, I did see you kind of put that into a Python script and kind of build a model very quickly, which I would kind of assume requires a little bit more specialistic knowledge. You know, this conference is all about knowledge and knowledge sharing. So suppose that for a second I would not know anything. So and I kind of would like to learn Flow ML in order to get started. What would be your recommended approach?
Sure. I think just a clarification over there. I would strongly suggest that a data scientist should be building the models and not, let's say, a non-data scientist. And the reason for that is it's very easy to go wrong given the uncertainties that we have listed in the slides. And a data scientist or a person who has invested considerable amount of time in working with data and learning about data would sort of avoid those pitfalls when compared to someone who has not gone through that path. Maybe just for an experiment, it might be okay for them. But if we are thinking about, if we are serious about productionalizing models and deriving value from them, it should be for a data scientist. And that's where, in my view, all the accelerators are for a data scientist and not for a
Yeah.
non-data
I
scientist.
think I think that's a very good clarification, because I was already kind of wondering how do you get started within that field if you don't have that specific machine learning or model building kind of background.
Right. Yeah, we can always wrap it over a UI. That's how the product goes out. But still, there are multiple pitfalls that I would rather not want our
Yeah,
customers to
I can
fall
imagine.
into.
Good. I think that's a very good wrap up of the session as you just described. Before I close the session, I just want everyone to kind of note the next upcoming sessions. Similar to earlier this morning, we have again 2 tracks which you need to make a difficult decision between. The first track is going to be continuing on the business path, and it's going to look at one of the speakers from MDEC. And this, I think, is a very interesting session around how big data analytics is used also specifically within the agriculture sector. It's a term which is called AgTech and AgTech adoption. And we're going to be welcoming Navin from MDEC to host that 1-hour session, which will start in around 20 minutes. For the people who would like to dive a little bit deeper, the second track that we're going to be looking at is a technical track. And in this technical track, Dr. Yu Yong Po from AirAsia Academy will be guiding you on how do you deploy a machine learning project in 2 hours. So that's going to be a bit more of a deep dive session. And Dr. Yu Yong is probably going to show, I would say, some of the models that Kishore just showed you, but probably a little bit more in a step-by-step approach. So depending on whether you would like to go a little bit more into the business side, or whether you would like to dive deeper into learning how do you build a machine learning algorithm, that's the choice you would need to make within the next 15 minutes before the next session starts. So with that, I would like to thank you so much, Kishore, for your very interesting presentation. I learned a lot myself, so that's always good to be on these sessions. So thank you much for sharing your insight during Big Data Days. This was really insightful, and I hope I can count on you again in any of our upcoming events.
For sure. Thank you, Jan. Thank you for the opportunity, and I hope the audience have learned a thing.
I'm pretty sure they will. Thank you so much, Kishore. I'm going to stop the session right now.